Hello friends, welcome to online lecture series of discrete mathematics. And now last session we have seen the overview of this complete graph. What is this complete graph? So again we will see what is this complete graph and examples based on this complete graph. A graph. So what is a complete graph? So we know in complete graph whatever vertices are present in a complete graph. That every vertex is related to every other vertex, right, in that graph G, right? Then we can say that the given graph is a complete graph. Generally this graph is denoted by this Kn, right? So n is a number of vertices. So here there are some diagrams or figures of the graph K1 through K6. So K1, so 1 is the number of vertices. So whatever complete graph is here, a graph with only one vertex. So K2, the number of vertices are 2. So there is one line is there, right? So every vertex is connected to every other vertex. Means where this vertex is connected to, so this is 1 and 2. So 1 is connected to 2 is connected to 1. So this is a complete graph. Same a triangle. So K3, number of vertices are 3. So every vertex is 1, 2, and 3. So 1 is connected to 3 and 2 also. 2 is connected to 1 and 3 also. 3 is connected to 1 and 2. So every vertex is connected to every other vertex. So this is a complete graph K3. Then K4. So number of vertices are 4. So whatever complete graph is here, a graph with the 4 vertices. So this is 1, 2, 3, and 4. So here every vertex is connected to every other vertex. Means whatever vertex 1 is connected to every remaining 3 vertices, 2, 3, 4. Again 2 is connected to remaining 3 vertices, 1, 4, 3. So every vertex is connected to every other vertex. So this is your complete graph. Again see in K5. So number of vertices are 5. Number of vertices are 5. Say K6, number of vertices are 6. And every vertex is connected to every other vertex. So this is 1 is connected to this also, 2 also, 3 also, 4 also, 5 also, and 6 also. So every vertex is connected to every other vertex. So these are the different diagrams or different figures shows the complete graph. So next, a regular graph. So what is a regular graph? A graph is said to be regular or k-regular if all its vertices have a same degree k. All its vertices have the same degree k. The graph whose all vertices have degree 2, then this is called as a 2 regular graph. If a complete graph Kn is a regular of degree n minus 1. So here question is draw a regular graph of degree 2 and 3. Means here whenever we have to draw the regular graph of degree 2, as per definition, all the vertices are of degree 2. So this is a 2 regular here. How many vertices are here? 4 vertices, V1, V2, V3, and V2. Every vertex is of degree 2. So this is called as 2 regular graph. Here, this regular graph here, again 4 vertices. Degree of V1 is 3, V2 is 3, V4 is also 3, and V3 is also 3. So this is a 3 regular graph. So 3 regular means what? Here, whatever vertices are here, every vertex is of degree 3. So this is called as a 3 regular. Then bipartite graph. Bipartite graph. A graph is called a bipartite graph if its vertices V can be partitioned into two subsets, that is V1 and V2, such that each edge of G connects of V1 to vertex V2. It is denoted by K to the base M into N, where M and N are the number of vertices in V1 and V2 respectively. So in bipartite graph, so whatever vertices are present in a bipartite graph is a partition into two subsets, is V1 and V2. So whatever partition here we form, remember that. So V1, whatever vertices are present in V1, these vertices are not related to each other, it's not connected to each other. And whatever vertices are present in V2 also, right? So these vertices are not connected to each other. But whatever vertices present in V1 may be connected to each and every vertices of V2. Getting? So this is your bipartite graph. Generally, this graph is denoted by the symbol this K to the base N. M is the number of vertices of V1 and N is the number of vertices of V2. So you can consider any V1 and V2 also. So this is the example here, right? Bipartite graph. Here, see first example bipartite graph. Here, V1, V2, U1, U2, U2, U3, U4. So here you have to partition, right? Here you have to partition this graph into a two, sorry, V1 and V2. So what is V1 here? You know V1. So this V1 containing. So V1 containing the vertices which are not connected to each other. So here V1, V2. These two are not connected to each other. Same V2 for V2 is U1, U2, U3 and U4, right? So it is U1, U2, U3 and U4. So V1 is one set and V2 is another set. But here this V1 is connected to U1, U2, right? Same V2 is connected to U2, U3 and U4. Right? So this vertex set V is partitioned into two subsets, that is V1 and V2. V1 and V2. So that is K 2, 4. K 2, 4. This V1 containing two vertices, V2 containing four vertices. So you have to remember here, then we can find out this bipartite graph, right? So number of vertices in bipartite graph is 2 plus 4, that is equal to 6. And number of edges in bipartite graph, right? So 2, 1, 2, 3, 4, 5, right? So 1, 2, 3, 4. Right? So number of vertices are 2 plus 4, 6. That is 1, 2, 3, 4, 5, 6. The next, this one is A1, A2, A3. This is one set. These three are not connected to each other. Same B1, B2, B3, This is another segment. This is your V1 and this one is your V2. So 2 plus, so there is a K. This is a bipartite graph of 3, comma. So number of vertices are 4. Number of vertices are 4. So stop here. In next session we will see complete bipartite graph and formulas for the complete graph also.